Okay, so let's take a look at this. First of all, example A. In example A, we notice we have a rational function, and a rational function will be undefined whenever the denominator is equal to 0. So in this scenario, whenever x is equal to -2. Well, let's investigate that a little further because we know discontinuities result from limits. So as I look at the limit as x approaches -2 of this function, if I were to plug that in, we would get 1 over 0. So then we know that this is a vertical asymptote. So if it's a vertical asymptote, then that means we have an infinite discontinuity. So we could say infinite discontinuity. Now, I could clarify this a little bit more by looking at the limit as I approach -2 from the left and looking at the limit as I approach -2 from the right. And so if I were to test values to the left and right of -2, so pick a number smaller than -2, like -3, it would be positive. If I pick a number greater than -1, like -2, like -1, it would also be positive. So then we can see that it is going to infinity and infinity. So that is what the asymptote would look like and the discontinuity. Now, looking at question B, I notice that I have a binomial linear over quadratic. So I'm going to factor that quadratic right away just to see what's going on. And so I've got a -3 and a -1. Well, the x minus 1's reduce out. So that tells me that's a removable discontinuity. So at x equals 1, it's going to be removable. Now I'm left with, when I reduce, I have 1 over x minus 3. And we know that if the denominator equals 0, we'd have a constant over 0. So this is going to be a vertical asymptote or an infinite discontinuity at 3. So that's the answer to part B. Okay, and then last of all, so this goes in this box. And then last of all, question C, we have y equals the absolute value of x all over x. Well, again, we know that rational functions are not defined. They have discontinuity when the denominator equals 0, so when x equals 0. But we do know, though, if we were to substitute and look at the value as x approaches 0 of this function of the numerator, we would get 0. And if we look at the denominator as x approaches 0, I'm sorry, let me write this accurately, of the absolute value of x. And then if we were to look at the denominator, we'd also get 0. So we basically get the indeterminate form. And so that means I actually have to do a little more work. I cannot assume that there is a vertical asymptote at this point. Now, this doesn't factor, there's no conjugate, there's no trig identity, so my normal algebraic routines won't work. So what I'm going to have to do is something different. I can do a table or I can do a graph of this function as I get closer to 0. So let's see, if I were to plug in the number 1, 1 over 1 is 1. If I were to plug in the number 2, 2 over 2 is 2. 1/2, it'd be 2 over 2 is 1. I'm sorry, then 1/2. So we can see that as I get closer to 0, coming from the right, the value is 1. Well, what if it's a negative? Well, if I plug in a -1, I'd get 1 over -1. So it's a -1. If I plug in -2, I'd get 2 over -2. Okay, so we can see then here we're approaching -1 from the left. So we now see that this is going to be a jump discontinuity because the limit as I approach 0 from the right of the function is 1, and the limit as I approach 0 from the left is -1.